Okay, so today we'll be solving additional mathematics, paper 1, session October November, year 2022, and variant 1 2, which is of 2 hours. Now, before starting, I have to make an announcement. That is, um, please do like, share, and subscribe this channel for more videos. So we are given with question 1, which is the diagram shows the graph of y is equals to a sine bx plus c, where a, b, and c are integers. Find the values of a, b, and c. So for it is given that it is a sine wave. So the sine wave starts from 0, and this is basically our line where the sine wave starts. So it has been shifted below. So this c would be -4, right? Now to calculate A, we have to measure the amplitude. This is the amplitude, so this would be -4 to -2, so this would be 2. We have our A as 2, our C as -4. We have to calculate our B. Now to calculate our B, we have to calculate how many waves um, made are being made in the minus pi till pi range, or you can say 2 pi range. So this is basically minus pi till 0 is pi range, and this is 2 pi, right? So if we look at it carefully, this is 1.5 wave. One wave completes here, and the half wave is here. The other half of that wave is here, and this is the complete wave. So we have 3 waves here. So our B would be 3. Now moving on to question 2, A part. On the axis, draw the graph of y is equals to 3x square plus 13x minus 10 modulus, stating the coordinates of the points where the graph meets the axis. We are given with y and x-axis. We have to first calculate the roots of the equation. So let's calculate the roots of the equation. So this would be, I guess, plus 15x, -2x, -10, and this would be equal to 3x, x plus 5 tries to 3x, x plus 5, then -2, x plus 5. We'll be having our x as 2/3 and x as -5, right? So we'll have our coordinates as -5 comma 0 and 2/3 comma 0. So these are our coordinates. So let's just write it down. So this, let's suppose this is 1, sorry, this is 1, so this would be 2/3, I guess. And if this is 1, 2, 3, I'm just sketching it, so this would be 4 and then -5. So these are our roots. So this would be something like this, or I guess I made some mistake over here. So let's just calculate the value of y when x equals to 0. When x equals to 0, y would be -10 modulus, so this would be y equal to 10, so this would be 10. So our graph would be this, something like this, right? But we have this as our modulus, so we'll be shifting this negative part towards the positive part. So this would be something like, let's just do the correction with the red marker. So this would be something like, this would be 10 and, sorry, just make it again. Suppose this is 10. This would be something like this. Sorry, we have the next thing over here, right? So this will be our final curve. This red part would be our final curve, right? Now moving on, we have our question 2 part B. Find the set of values of constant k such that the equation k is equals to this has exactly 2 distinct roots. It has to have the 2 distinct roots. So if you look at it carefully, we have 2 distinct roots only over here, right? The other line will have 1, 2, 3, and 4 roots, or this will have the 4 roots, this will have again the 4 roots. This is the only part where you will find the 2 roots only, right? So let's just calculate, do some calculations. So this would be 3x squared plus 13x minus 10. Let's remove this modulus sign. So this would be negative k equals to 0. And since it's two distinct roots, it is given as two distinct roots. So b square minus 4ac, that is our discriminant, would be greater than 0. Our b is 13, that would be squared, negative 4, our a is 3, and our c is minus 10 minus k. We solve this and we get our answer as 169 minus 1 plus 120 plus 12k is greater than 0. So we get our k as 289 over 12 negative. So this, the k has to be greater than 289 over 12, and the k can't be negative because it is actually modulus, right? So k should be equals to 0 when it has to have two distinct roots, right? Moving on, we have our question 3. Write this whole part in the form of this k p power a, q power b, and r power c, where k, a, b, and c are constant. Now this is simply indices of O level maths, or you can say IGCSE maths. Indices, right? So let's just solve this one by one. So this would be 9 powered 1 over 2, or 9 square root would be 3. P squared multiplied by 1 upon 2 would be p. This is 2 multiplied by 1 over 2, so this would be 1. And this would be q powered 1 over 2. When we remove the square root part, we give the power as 1 upon 2. And our r would be same. So let's just remove this multiply sign. So this would be negative 3. We have in the denominator as 2 cube would be 8. Our p cube would be as it is. This would be q negative 1. This would be r, since this is rooted 5. So this would be 1 over 5. Now let's solve this. So this would be 3 over 8 again. P3, P1 minus 3 would be P minus 2. This would be P negative 2. And this q negative 1 would go above. So this would be 3 over 2. And this r1 over 5 would go up. And this would be negative. So this would be r negative 16 over 5. You can use the calculator over here, right? So this would be negative 3, negative 1 over 5. You can use the calculator. So you will get our answer as negative 16 over 5, right? So we have our question 4. We'll solve the equation this for x should be in between 0 till pi. So we have this equation. Sine and cos are given. So that would be simply sine over cos. That would be tan. So let's just move them a little bit. So this would be cos will go over there, and this 3 would go in the denominator. So this would be root 3 over 3 sine over cos, and 2x plus pi by 4. This sine over cos is basically tan, and this tan would be inverse over here. So this would be tan inverse root 3 over 3 2x plus pi by 4. Let's just calculate. So this would be in first and third quadrant, because tan is positive in first and third quadrant, right? So we get our alpha is pi by 6. So our thetas would be, that would be 2x plus pi by 6 would be pi by 6, 7 pi by 6. This is basically calculated by pi plus 6. So this is our third quadrant's equation. So this is basically 180 plus alpha, right? So again, the next would be 13 pi by 6, which completes a round of 2 pi. So the 2 pi would be added in pi by 6, right? So when we solve this, we'll subtract pi by 6 from this and divide it by 2. Now since 0 is not included, we'll reject this and we'll use these two to get our answers, and our answers would be 11 pi by 24 or 23 pi by 24, right? Moving on, we have our question 5 in the vectors part. This is given as find the vector with magnitude 200 in the direction of this. So we are given with the direction. Let's calculate the magnitude of this direction. So this would be 7 squared plus 24 squared, and under root this would be 25. And we are given with the magnitude of 200. So let's just divide this 25 by 200. So this would be 8. So we have our magnitude of this. So this would 8 would be multiplied by the direction given. So this is our final answer. You can keep it over here, or you can just multiply it by to get our final answer. Right. So we have our part B, in which a triangle is given, right? So we are given with OA as A, OB as B, and we have AC and AB as 1:3. So this is basically 1, and this is basically 2 parts. Find the vectors, find the vector OC in terms of A and B, giving your answer in the simplest form. So OA is given as A, OB is given as B, AB is OB minus OA. So this would be B minus A. We are given with AC is to AB ratio, which is basically 1:3. We have been given with AB, so this would be multiplied over there. We get our AC as B minus A over 3. We have to calculate OC. So we have our AC, which is given as OC minus OA. We have to calculate this, so this will go and will be added with AC. So we have our AC as B minus A over 3 plus A is equals to OC. And when we calculate this, so we'll get our answer as B over 3 plus 2 over 3 A as our OC, right? Moving on, we have our part C as given the vector equation this, find the value of P and Q. So basically this is a simultaneous equation. Let's just create this. So this would be 2P plus 2P and P. This would be 2Q and 4Q. This would be negative 5P plus 5, and this would be 5P plus 5Q. We have our first equation as 2P plus 2Q is equals to negative 5P plus 5. We can rearrange it to get our answer as simply for 7P plus 2Q is equals to 5. This is our first equation. This would be our second equation, which is given as given as, so we take this 5P over there, so this would be negative 4P. This Q will be going over there, so this would be negative Q equals to 0. So this is our second equation, right? We can multiply it by 2 and subtract it, or sorry, add it with this equation. So we get our answer as 7 negative 8P would be negative P. This would be cancelled out, and this would be 5. So our P is given as negative 5, right? And our Q would be, let's just plug it in over here. So this would be negative 7, 7 into negative 5 would be negative 35, and this would go over there. So this would be 40, and then 40 divided by 2 is basically 20, right? We have plugged this minus 5 over here. So this would be 7 negative 5 plus 2Q is equals to 5. This would be negative 35. This would be positive 35 over there. So this would be 40 is equals to 2Q. Q is given as 20 in our answer, right? Now we have question 6. A group of 15 people includes 3 brothers. A team of 6 people is to be chosen from this group. The 3 brothers must not be separated. Find the number of possible teams that can be chosen, right? So we have 2 cases over here. Case 1 would be to include both brothers, and our case 2 would be to keep the brothers out of the team, right? For case 1, We have our three brothers selected, so this would be 3C3, and we have to select the other three from 12. So this would be 220, and if we you see the case 2, the three boys are out of the equation, so we have to select 12. So we have to select 6 from the 12 team. This would be 924, I guess. Yes, and we'll add this up, so we'll get our answer as 1144. This is our final answer. Moving on to question 7, we have the diagram shows a circle center O radius 10 centimeters. The points A and B lie on the circumference of the circle. The tangents A and B, the tangent at B meets at the point C. The angle AOB uh, is in radians. The length of the minor arc is 28 centimeters. So this is basically 28 centimeters, which is given. Other than this, everything is given over here. So first of all, we have to find the value of theta. We have our r as 10. Simply plug in the formula of s is equals to r theta. Our s is basically the minor arc that is of AB, and we have our r as 10. We'll get our theta as 2.8, right? So this is our theta. Now we have to find the perimeter of the shaded region. Our perimeter of the shaded region would be AC multiplied by 2, because this would be AC and BC would be added, and this 28 will be added directly, right? So to calculate the perimeter, we have to have the length of AC. Now since this is the tangent, this would be 90 degrees. We have this 10. We have this theta, that is 1.4, because altogether it is 2.8, and this would be a bisector. So this is 1.4, right? For perimeter, we need 2 times AC plus the minor arc of AB. This is basically 28 already given, and we have our perimeter as this is given as this will be, we have to calculate this. So this is basically perpendicular, this is base, we have to calculate, we have to use the tan formula. So this would be tan 1.4, and this is basically perpendicular over base. We have our base as 10, so this 10 would be multiplied, and this would be AC, right? So we have to add this 10 to 1.4 and then multiply it by 2 and then add it to 28. So we get our final answer as 220 tan 1.4. Do we have a scientific calculator? I guess. Do we have radians over here? I don't think so. We have. Sorry. Let's just. Do we have something? No. Radians. Do we have something like radians over here? No, I don't think so. No, we don't have something like radians over here. I guess. No. It's giving the answer in. So you can calculate this by yourself by adding these both. You get the perimeter of the shaded region, right? So we have now we have our part C as find the area of the shaded region. The area of the shaded region would be let's just this, that would be this complete, or 2 multiplied by area of triangle, and then this area subtracted. Sorry, let's just take the different pen, and let's just subtract this to get the final area, this, the shaded region, right? So we have to subtract the sector area, right? So we'll have the area of the triangle as, we have our base, that is this 10, and we have our AC as well, that is our height, or you can just flip it, right? So this is 1/2 multiplied by tan and then this 10 1.4 is multiplied. This is subtracted by the area of sector. We have our area of sector as 1 upon 2 r square theta. So we have our r as 10 and our theta is 2.8. By solving this, we get this as 140 and we get this as 50, 10, 1.4. This is 5, this would be 5, this would be 50, and 50 multiplied by 2.8 is 140. So we get our final answer as 439 or estimated as 440. Right? Moving on, we have our question 8 of function, where a function is such that f of x equals to this, x has to be greater than 0. For x has to be greater than 0, we have to make sure that this part is basically greater than 0. So we can use 2x plus 3 equals to 0, x would be negative 3 upon 2, x has to be greater than negative 3 upon 2. So we have our a as negative 3 upon 2. Using your value of a, write down the range of f. Now since it has to be greater than negative 3 upon 2, it can go anywhere in the range of f. So we can write this as f belongs to a real number. See, using your value of a, find f inverse x stating its range. We have to state the range of f inverse x. So the range of x would be the domain of f, right? Inverse, or when we use the inverse, its range is basically equal to the domain of f of x, right? So we have our range of f inverse x as greater than negative 3 over 2, right? So we have our range first. Now let's just calculate the f inverse x. So we have been given as ln 2x plus 3 plus ln 4. This was our equation. And then we can solve this. We can multiply these both. So this would be, and just make it a single ln. So this would be 4 into 2x plus 3 is equals to y. This ln would be removed and this y would go in the power of e. This would be 8x, or let's just keep it like this, and then divided by 4. So this would be 2x plus 3, and then this e power y over 4 would be subtracted by 3, and this whole would be divided by 2. So we get this as something like this, or we can solve this as to get e power x negative 12 over 8, I guess. This y is basically shifted to x. So this is our f inverse x finally. This isn't, let's just remove this, right? So in part D, we have on the axis below, sketch the graph of y is equals to f of x and y is equals to f inverse x, stating the exact intercepts of each graph with the coordinate axis, and label each of your graphs. Well, now I'll be extracting the intercepts of each graph. It will be a very rough graph. I would suggest that you should be doing it yourself. So this is given as f of x would be given as, for f of x we can calculate x, when we have x as 0, we will be having our y as ln 12. You can just see it over here. So this would be ln 3 and this would be ln 4. 4 and 3 would be multiplied, so this would be ln 12 finally, right? Now if we use y equals to 0, we get our x as, sorry, just keep y over here, we get our x as negative 11 over 8 when we use the calculator. We have to use the calculator over here. This y would be used over here. So this would be 0, this would be e power 0, this would be 1, and then this would be simply used, right? This would be 4 would be divided, and then 2x plus 3 is left. So this would 3 would be subtracted and 2 would be divided. You get the point, right? And you can calculate it exactly. Now in f inverse x, what happens is y and x are flipped, basically, nothing more, right? So this is our final working. You can do it on your rough paper as well. Now let's just plot it first. So this would be negative, let's just suppose this is negative 11 over 8, and this we have negative 11 over 8 over here, and we have ln 12 over here. Let's just this should be ln 12 over here. Let's just suppose this, right? So we have our f of x, where when y was 0, it was x was our 11 negative 11 over 8, and our y when x well, when our x was 0, our y was ln 12. So this would be something like this, since it can't go beyond negative 3 upon 2, right? Remember in the first part this was red. Um, it's a pretty rough sketch for now, and then this would be something like this. F of inverse of x would be something like this. This would be negative 3 over 2, and this would be our um, what you can say is asymptote, right? So this is our final sketch. Again, it is a sketch. I would recommend to you to draw it on your rough paper, right? Now moving on, we have question 9, where a part is show that this is basically equal to this. We have to take the LCM. We have to multiply this by 2x plus 1 is missing over here, and this 4x minus 1 is missing. Here 4x minus 1 is missing. We'll be multiplying it to denominator and the numerator both. Here whole 2x plus 1 whole squared is missing. Let's just complete it. So this would be 2x multiplied by 4x would be 8x squared, and our this 4x would be multiplied by 1, and then this would be negative 2x. So this would be finally written as plus 2x, and this would be plus 1 minus 1 would be negative 1. This will be multiplied by 4x minus 1. So 4x, this would be simply 4x minus 1. This will be multiplied by negative sign because it has a negative sign over here. And then this would be multiplied by 2x plus 1 whole squared. So this would be, and then multiplied by 4. Let's just multiply it by 4 and then multiply by 4 and square it as well. So this would be 2x squared would be 4x squared. That would be multiplied. So this would be 16x squared. And this would be 2 into 2x would be 4x, and then this 4 would be multiplied, so this would be 16x again, and this will be 1, and this would be multiplied by 4, so this would be 4. We have our denominator as 2x plus 1 whole squared, 4x minus 1. We have our next step. So this would be 24x squared, this 2x, negative 4x, and then positive 16x would be added to get our final answer as positive 14x. And this 4 would be added in, since this negative 1 and negative would be positives, this positive 1 and negative 1 would be cancelled out. So this will be left with positive 4, and we have our denominator as 2x plus 1 whole squared, 4x minus 1, right? So we have proved it, which was to be proven. Now we have our part B as hence find this integration, giving your answer in the form 1 upon 2 ln p plus q, where p and q are the rational integers, right? So we have to give our answer as something like this. Okay, so let's start. So this would be 1 over 2x plus 1. I'm just simply writing this as this. This would be negative 1 over 2x plus 1 whole squared, and this would be plus 4x minus 1. We can just rearrange it and move this part over up to the numerator, right? Other than this and this would be ln, so that we can keep it in the numerator, right? So this would be 1 over 2x plus 1. This can be written as this, negative 2x plus 1 power minus 2, and then positive 4, 4x minus 1, right? So this would be ln. For that we need to have the we have to have the um, differentiation of this 2x over here. So we don't have, we if we don't have it, we can multiply and divide it by 2. This 2 would be multiplied and we'll get our ln. So we have our 1 upon 2, because this 2 is already multiplied to get our ln 2x plus 1, but this 2 is left in the denominator, so this is written as this, right? So now moving on to the next part. So this would be negative 1, power would be added, so this would be negative 1, and this would go in the denominator again, so this would be 2x plus 1, and again this would be plus, and this differentiation, since this is negative 1 and this negative 1 would be multiplied over here, and this differentiation would again be multiplied. This was negative over here, so this negative 1 and negative would be multiplied to get our answer as positive, right? And then this 2 would be multiplied. Let's just keep it over here. So this would be ln, this would be ln, we have our differentiation above, so this would be simply ln 4x minus 1. We have to apply the limits of 1 and 1 upon 2, since it was given in our original question. Let's just apply the limits. This would be 1 over 2 ln 3 plus, and we have applied the 1 part, so this would be 2 plus 1 3. This would be 3 and 2 1 over 6. This would be 4 minus 1, that would be ln 3. This is the upper limit. Now subtracting the lower limit, our lower limit would be negative 1 over 2 ln 2 negative. This would be 1 over 2 and this 2 would be cancelled out, so this would be 2. This would be 2 multiplied by 2, that would be 4 plus 1 over 4, and if we multiply 1 over 2 over here, so this would be 2 minus 1, that would be 1. ln 1 is basically 0, right? So no need to write it. Now if we solve this, we get our answer as this would go in the power, so this would be ln 3 powered 1 over 2 minus ln 2 1 upon 2, and this 1 upon this 1 would be added, so this would be 3 upon 2 because the powers are added. So this would be negative ln 2 1 over 2, and then this, if we subtract 1 over 4 from 1 over 6, so this would be negative 1 over 12, right? Now let's just solve this more. So this would be ln 3 power 3 is 27, so this would be 27, and this would be again 2, so we can keep this power as 1 over 2, right? So this would be negative 1 over 12. We have our final answer, right? We can move this 1 over 2 over here, so this would be 1 over 2 ln 27 over 2 negative 1 over 12. So this is our final answer. Now moving on to question 10, we have the first three terms of an arithmetic progression as this, where x has to be greater than 0. Show that the sum to n in n terms of this arithmetic progression can be written as this, where p is an integer, right? So let's first calculate the common difference. Our common difference would be t2 minus t1. So this would be written as 5 lgx, or you can just simply move this 5 over here. So this would be 5 lgx minus lgx. This would be 4 lgx, right? We have our common difference. We have our first term, that is lgx. We can use the sum to n terms formula, that is Sn n over 2. This formula is given in a formula sheet, right? So this is our formula. By plugging in all these, this is a and this is d and this is our a, we'll be plugging in. This would be n over 2 lgx, this is multiplied, so this would be 2 lgx plus n minus 1, and our d is 4 lgx, right? This is negative 4 lgx and this is 2 lgx, so this would be n over 2 4n lgx, sorry, negative 2 lgx, right? So if we divide it by 2, so this would be cancelled out and this would be simply written as n 2n. Let's just take lgx as common as well, so this would be 2n minus 1, lgx would be common. So we have our final answer as this, right? Now moving on, we have our part B as hence find the value of n for which the sum to n terms is equal to 4950 lgx. So let's just keep this, use this value, use this value over here. So this would be 4950 lgx equals to n 2n minus 1 lgx. This lgx and lgx would be cancelled out, and we'll be solving a quadratic equation over here. So this would be 4950. Then we can use use the calculator over here, and we'll get our answer as n is equals to 50. We'll be ignoring the positive value because the n can't be. We would be ignoring the negative value because n can't be negative, right? Now moving on to part C, we have given that the sum to n terms is also equal to negative 14850. Find the exact value of x, right? So we can use 4950 is the lgx equals to negative 14850. We can divide this by negative 14850. This would be 4950. This would be cancelled out and this would be multiplied by 3. So this would be lgx. To remove this lgx, we'll move this into power of 10. So this would be x 10 power negative 3, right? So if we move lgx equals to 3, we have to remove this lg. We can move this into power of 10. So this is basically like written like this, right? And it can be written as 1 over 1000 as well, right? Now moving on, we have our question 11. I think is the last one, or we have the next one as well. So particle P moves in a straight line such that t seconds after passing through a fixed point O, its displacement s meters is given by this. Show the velocity. Velocity means the differentiation of displacement at time t can be written as this, where a and b are the integers to be found. So we have to use the quotient law over here. We have velocity as ds over dt, which is the differentiation of displacement. We have to use the quotient law, which states this is our v and this is our u function. This would be v u dash, which means u dash means the differentiation of u, and u v dash means the differentiation of v. V squared is basically v square. So if we write v, v would be t plus 1. Our u dash would be our u dash would be this 3 over 2 would be coming over here. So this would be 3 over 2 power down. So this would be 3 over 2, and then the differentiation of the function, this would be 2 again, and this 2 and this 2 would be cancelled out. We will write this whole by divided by t plus 1 whole squared, and then we have negative sign over here. We have our u as 2t plus 1 power 3 upon 2, and we have our differentiation of v as 1, right? So let's just separate these first. So this would be 2t plus 1 power 1 over 2. This would be power 1 upon 2 because 3 over 2 minus 1 would be negative 1 over 2. This would be negative, this would be 1 over 2, and this would be t plus 1 whole squared. We are left with this 3t plus 1 and 2t plus 1 power 1, right? So this would be 3t plus 1 and negative 2t negative 1, since it's negative, right? This would be negative. So we have our final answer as 2t plus 1 power 1 over 2 t plus 1 whole squared, and this would be t plus 2. 3t minus 2t is basically t, and this 1 and negative 1, sorry, I guess we made some mistake over here. This is basically 3. 3 is multiplied over here, right? So we have our plus 3 minus 1, this is equals to 2. Now in part B, we have show that P is never at instantaneous rest after passing through O, right? So we have to plug in, we have to keep it as 0, right? We have to keep the velocities expression as 0. So velocities expression is given as 2t plus 1 power 1 over 2 over t plus 2 whole squared, and then t plus 2 is multiplied equals to 0, right? So this can be either 0 or this can be either 0, right? So if t plus 2 is 0, then t has to be negative 2, and t can't be negative 2, right? Time can't be negative, right? And if we use this, we have 2t plus 1 power 1 upon 2 t plus 2 whole squared. We'll be multiplying 0 by t plus 2 whole squared, so this would be again 0. We have this as 2t plus 1 power 1 upon 2 equals to 0. This can be removed by squaring this, so this would be 0 again, and this would be negative 1 over 2. This minus 1 will go over there, and this 2 would be divided, so this would be negative 1 over 2. We have our t as negative 1 over 2, and this can't be possible because t can't be negative, and p is never at instantaneous rest after passing through O, which is t is equals to 0 when t was equals to 0, right? So it can't be at instantaneous rest after passing through O, right? We have proved it. Now moving on to question 12, we have the first three terms in descending powers of x of expansion of this can be written as this, where a, b, and c are constants. Find the exact value of a, b, and c. It's a 9-marker question. It's a very long question. Let's just simplify this first. So this would be 1 powered square. This would be 1. And then this would be 2c1 is basically 2. And this would be 1. Let's just not write 1 again, because 1 powered anything is 1. This would be b upon x, and we have our last term as b over x whole squared. So this was a pretty simple one. Now if we use this, we have to have the first three terms, right? So let's just calculate the first three terms of this. So this would be ax powered 5, right? And this would be 5c1. 5c1 is basically 5, so let's just write 5 over here, and our ax would be powered 4, and our 2 over 5 would be powered 1. Moving on, we have 5 ax powered 3 and 2 over 5, sorry, ax as whole powered 3. I guess I wrote something wrong, because this wouldn't be 5. This would be 5c2, and 5c2 is basically 10, right? So we have this and this both, right? We have to calculate this first. So this x powered 5 would be simply 1 multiplied by ax powered 5. So this would be a powered 5 x powered 5 is equals to 32 x powered 5. This x powered 5, since we need to compare the coefficients, this would be a powered 5 equals to 32. Anything to the power 5 equals to 32 is basically 2. So 2 powered 5 is 32. We get our a as 2. We have our a. Now we have to calculate b and c. So for b, we can multiply this 1 by this value and this by this, because if we multiply x by x powered 5, this would be x powered 4, and if we multiply 1 by x powered 4, so this would be again x powered 4. Let's just multiply it. 1 would be multiplied by 5 and this, so this would be 5 and 5 would be cancelled out. We get our answer as ax powered 4, and this is multiplied by 2, so we have this as 2ax powered 4, a4x power 4, and in this we'll have negative 2b over x is multiplied, so this would be x is divided by this, so this would be x powered 4, and we will be having this as a power 5, right? So we have this. Let's just plug in a's value. Our a would be 2, so this would be 2 power 4 16. We have our x power 4, then this would be 2b. We have 2 power 5 as 32. this is x powered 4, and x powered 4 coefficient is 160 x powered 4. We can just take x4 as common and just remove it. So this would be 32 minus 64b. This 2 would be multiplied, equals to 160 plus 32 would, or you can just move this over here. So this would be negative, sorry, this is negative 160. So this 160 will come over here. So this would be 32 plus 160, that is 192 is equals to 64b. This 64 would be divided, and 192 divided by 64 is basically 3, or just b is equals to 3, right? So we have our b. Now we have to calculate our c. C is basically x cubed coefficient. So for x cubed coefficient, we can multiply this 1 by this coefficient, right? We can multiply this x squared coefficient by this, and this basically by this, right? So let's just first multiply 1 by 10, this thing. This would be 10, and 25 would be divided. We have our a cube, so we just write it down, and this would be 4 over 25 since this is squared, and a cubed, x cubed, right? Yes. And then this will be multiplied by this, so this would be 5 and 5 is cancelled out. We have our 2a 4, and this is basically x cubed. 2 and 2 is multiplied, again 2 is multiplied over here, so this would be 2b again, I guess, and this is basically x cubed coefficient, right? And this is negative, right? So now we have to multiply this by this, so this would be b squared a power 5 x cubed. This is equals to cx cubed. We can cancel the x cubes and just calculate it. This is basically 2, so this is 8. Let's just cancel this, so this would be 2 over 5, and then 8 into 4 is 64. Sorry, 8 into 4 is 32. 32 into 2 is 64. Divided by 5 would be as it is, and this is our x cubed coefficient, and this would be, since it's 2, 2 powered 4 is 30, 2 powered 4 is 16, 16 multiplied by 2 is 32, and this 32 is multiplied by 2 is 64, and this is b is 3, 64 multiplied by 3 is 192. This would be negative, and then this would be positive, which is b squared is 9, and our a power 5 is 32. So when we solve this, we get our c as 554 over 5, right? So sorry, all right, so we have this. We can use the calculator over here, calculator, and we get our final answer as this. All right, so this was it from my side. Thank you for watching, and please do like, share, and subscribe our channel. Thank you.